This week, we're off to Kilmarnock to the power signal box built in 1976, replacing 4 previous mechanical signal boxes. The power signal box controls 3 routes. 1 track circuit block, 1 operated off the Scottish Region Tokenless block system, and 1 worked off the absolute block system, with the Glasgow and South Western railway blocks still in use, and we'll get a look at them. We'll also get a look in on the relay room at some of the geographical circuits in use, thanks to our colleague Peter Ramsay and Lynsey Hunter. So without further ado, let's jump right in.
And the usual acceptance switch, normal and reverse, the open cancel, the sealed cancel, and the bell plunger. So this is the tokenless walk line to Lawton. And then this single line going to Ramsay is track circuit block. Used to be tokenless block when there was a signal box at Ramsay, but when Paisley took control, it became just axle counter track circuit block.
Should we get your green?
The Glasgow and South Western railway block instruments were created by Tyres & Co. These were to a 1-wire 2-position instrument originally, though following an accident at Ayr in 1913, 3-wire instruments and extra indications were fitted. This one is fitted with a gong. Some were fitted with bells and gongs, denoting which was the up and down lines, and Peter will explain a little bit of this in the video. So without further ado, let's have a look at these instruments in use.
So two line wires, 2 of them are for the arms and the 3rd line wires for the disc. And originally it had been on a longer backboard with a separate bell plunger underneath, which is what this is. So if you're just rigging, code rigging, you use that plunger. If you want to change the block indications, you use this plunger. When they added the 3rd indication. So these are proper 3-position block instruments, which is probably why they've survived, because they are 3-position blocks. The Cali version of this was a 2-position block. It just had a red and a white plunger on the front. So white for line clear, red for train on line or line blocked. And it just had the semaphore arms to indicate line clear or line blocked. It didn't have the disc. So the disc feature here is unique to the GNSW. So they added the disc feature in about 1905. There was a serious accident at Ayr station, and the Board of Trade insisted they had 3-position blocks. So they added an extra line wire to the circuit and this little disc which says online. Yeah. So when you go to train online, the arm goes back up and the disc goes across to online, and that's when you plunge out of section back to normal, the disc disappears again. So I think that's why they've survived as long as they have. Made by Tyres, Tyre & Company instrument.
So if you get a line clear and then have to cancel it, it's the process for cancelling.
So if you give a line clear, you need to cancel, basically you need to, so that's our down main line welding. So we just hold that in.
That's a timer.
Yeah, and once the light comes on, then that's you'd be fine to get a line clear. So you usually do that, see if you're like testing. So if Mockler need to do a test for them, you give them a line clear, then when they're finished you would just hit the welding and be fine.
Cancel the route, double button up, and put it back. It's 2 in 1 for the outer section. It used to be track circuit block to Hurlford from here, and Hurlford was the start of the. So package relays in sets, which each set represents a particular function, either points or signals or ground training. and they're arranged in numerical or geographical order, slide the layout inside. The sets are built in the workshop, pre-assembled, pre-tested, and then they're connected on site with individual wires, terminal boards at the top and bottom.
So you're effectively buying a block, you're buying,
You're buying a function,
you're buying a
quite
function
small.
rather than a three-wired interlocking where you just buy the simple individual relays that are being. So it does end that you can end up with surplus
Yes, you can end up
because
with
you might have a
hundreds of-
function that you don't need.
So the set is designed to provide almost every function you might need. You get a single point set, a bonded point set. Some signal sets you get two signals in one. If it's a shunt signal, you get the left hand half is one shunt, the right hand half is the opposite shunt. The system is based on AEI GRS, Geographical interlocking, which was first deployed in Scotland at Norhill Yard in 1960. And the big system was deployed at Paisley and Inverclyde lines in 1966. So Scottish Region engineers liked the design, so they copied it essentially and improved it a little bit, and this became Scottish Region Geographical. The original EI system has a big 50-volt stick battery to hold the root relays up from power fails. Our Scottish engineers changed it to use a latch relay for the root relay. So if the power fails, the relay stays latched up and it saves you the big 50-volt stick battery. That's basic difference is this one uses a latch relay for the UR, and the original system didn't. What can we say? This set here is for the tokenless block system. This is the polar relay, the LR, which senses the polarity of the circuit to locked-in. And this little relay here, the telephone relay, is the XR, which is the bell relay, which rings the block bell through here in Lockton. And then the relays down here are the standard tokenless block relays, the NPR, RPR, NLR, RLR, etc. CSR, which would be ZSR there as well, ZSKR. So that's what operates the single line system, interlocking system. So this is the little special bit at the end. And then these are the main sets. So that's number 56, main and sub. So this controls the main signal with the subsidiary aspect. This is number 25 points. It's a single point set, so it's a single and a set of points. This small number of relays is a double ground frame set, so this controls two ground frames. This one's still in use, and this side has been taken out of use, so there's no relays on a relay basis. Polarity for line clear, opposite polarity for trailing line. So these polar relays prove what polarity has been received from the other end. So one is in the pegging circuit and the other is in the non-peg circuit. So the system can see what polarity the signal is sent and operate the interlocking accordingly. So these are made by Tyres as well, Tyre & Co. Lovely big bits of electrical engineering, these brass case.
They're beautiful actually.
And these would all have been regularly reserviced at other workshops just down the road, and everyone used to exist. Probably every 10 years they go back and be reserviced and recalibrated. So your block, which probably goes back to the 1930s. Again, block lines. When the plunger's not pressed, the block lines are connected to the BXR, the non-peg block indicator, and the BCR, which is that lovely big brass case relay along there. So normally the BXR, BCR and block indicator are across the lines. Here the plunger and the separate tapper, not pressed. When you press the plunger to send an indication, you then connect the peg indicator and the pegging BCR to effectively to the battery.
Yep.
And the polarity, line clear or trailing line blocked, is just determined by the commutator.
Yeah.
So line blocked and trailing line sends one polarity, positive, to to return, and line clear sends positive to line. These contacts here are for the block controls, so this is what forces the blocked train on line. If the signalman hasn't sent the train on line when the train occupies the berth track, drop the berth track TPR, and that will drop the block relay, the BR, which will force the block to go to arm up online automatically. So that's the circuit for block indicators. Here's the block bell. So the BXR responds to line current, the block bell relay. BXR rings the block bell and operates the magnetising coils. So it provides you have two magnetic fields at right angles to make the arm move. So the local coils are operated in the bell circuit, and the line coils are operated by the line circuit. So with these two magnetic fields being at right angles to each other, cause the arm to move. Then, so the Cali block was exactly the same as this. It was a two-position block with 74 arms. The GNSW special bit is the disc indicators here. So you've got the down main line, train on line disc, non-peg, and the up main line, train on line disc, peg. So this was the GNSW's addition. So a separate battery and effectively an extra line layer.
Yes.
On Earth, which they didn't have before.
Common return.
Common return, yeah. And also sharing this return. So this circuit operates over these two wires, and this circuit operates those two. So three altogether. So basically, again, extra contact springs worked by the commutator, which again just control the polarity going through the disc to flick it to online or blank to give you the third indication. And the block controls are up here. And so you've got the berth track. There's the TPR here, which also drives the TPS. And the TPS drops when the berth track occupies, and you can only pick it back up again when your signals are back at danger and blocks being proved to be at train on line. That's the contact made, you turn it to trade on. That picks up the TPS again. The BS is what picks up when you peg line clear. So the BS has to be up to get the correct polarity for line clear. If the BS is down, your line clear polarity goes out on the return. So you just get train on line even if you wanted line clear.
Are they China resistors or are they lamps?
No lamps. The TXRO is 3 metal filament lamps, usually with LMS engraved on them.
Yes.
On the so that's the track timer. The 3 lamps and the TXR relay in a little wooden box.
So it shuts itself up after the track's been down for 30 seconds.
Picks up initially when the lamps warm up and the resistance increases and the TXR drops. And that only works when the berth track's occupied, and sometimes they have a home signal normal contact as well, so it only buzzes if the signal's at danger.
And here are those 3 very lamps engraved with LMS that Peter's just mentioned.
This is the Welland, as the guy said, it's a mechanical Welland timer, manual race. So the Welland just effectively simulates the train occupying the berth track and picks up the ZS, which then sticks itself out. So the ZS is and the BR associated with the Welland. The BS is the normal controls, so you can't send a line clear unless you've proved your home and distant are both normal. So home, distant, lit, lamps lit, and 18 I think will be the home signal. Sorry, these are the home signals, these are the normal bands in the home, and the GCRs are the distance for the So you have to have the normal conditions met before the BS can pick up.
So that's the Sunday battery.
That's called the Sunday battery, but the switch is a switch on the block shelf. It usually says Sunday switch, so that just switches in or switches out the N cells, which are always DS1s or dry cells, to give you extra oomph.
When the box is shut.
Tokenless block system doesn't need that. Tokenless block system is quite clever. If Wharton was switched out, then the LR operated these relays locally, which then fed the
extra
voltage on. So the Scottish tokenless box system was designed to be self-repeating.
Yeah.
So when it switched out, you didn't have to do anything extra. It just
You just keep
it
repeating
just
and
went
repeating
from
it.
section to section. You could switch several boxes out in a row if you wanted. But each one would keep operating locally. And the indications were available locally as well. So the second
Right.
you came to switch in, you could see
You can see what stays
what was in the section. So that's a quite good feature of the design. Here it's a manual switch. So yeah, classic locks, blocks and bells.
So we hoped you enjoyed that little look around Kilmarnock Power Signal Box and some of the circuitry. And thanks to Peter, our colleague, and Lynsey, we get to see more and more of how the railway actually is controlled, especially with some heritage signalling equipment. Have a safe journey.